Hey everyone, this is Kyle with DJI. Thank you all for joining. I know it's at the top of the hour here, and usually on webinars, we wait a couple minutes for everyone to roll in. We'll give it 1 minute, but we have got a lot of conversation, a lot of topics to cover today, so we are going to get started here in just a moment. All right. Cool, some housekeeping things as we get started. On GoToWebinar, you should see an area where there are questions, or at least the chat. You can message any questions and all three of us will be able to monitor those as we go through. Also, this session is being recorded. So if you have to drop off for any reason, or if you want to share this and you found this interesting and share it out, we're going to be publishing this on our YouTube channel, usually within the first 2 to 3 days after the webinar. So we will have this recorded, and we are very, very excited to talk about digital twins and some of the updates that DJI has there. So with the agenda, very briefly, we're going to be talking about mission planning, data capture, data processing, and then data analysis. It's as simple as that. How do you go out and capture the best data? How do you process it? And then how do you share it to the world? So with that, let's go ahead and do a quick round of introductions. Since I'm already going, my name is Kyle Miller. I'm on the solutions engineering team at DJI. Been here for about 2 years, and my specialty on the DJI team is more of the geospatial side. That's the industry I focus on. Ted?
Hey everybody, I'm Ted. I'm coming to you live from Canada, and I run SkyDeploy. I started SkyDeploy as a drone services business back in 2017, and since then I've been obsessed with taking pictures of ground and concrete and turning it into 3D objects. So pretty cool to be here and talk about what I love to do, and so I can keep doing it. And I hope you guys get to learn as much as possible from this, and we'll see where it goes.
Thanks, Ted. And Ron?
Thank you, Kyle. This is Ron Lee from DJI Enterprise Solution Engineering team. I work with Kyle within the same team and been with the company for about 6 years now, and been focusing on photogrammetry, reconstruction, reality capture technology from enterprise solutions.
Great. Well, you mentioned 6 years, Ron. Well, that's pretty dang impressive. Since you've been around at DJI for quite a while on the geospatial side, I'll let you walk through the history of that.
Thank you, Kyle. So actually 2018 is the year I joined DJI, which is kind of nice. By the time we have announced our first photogrammetry focus or reality capture focus drone, which was meant to design for capturing high accuracy / high precision geographic data. That is the Phantom 4 RTK. It was the first RTK drone that has every components needed. And ever since then, we've just been adding more components within this solution package. And 2019, we have released our DJI Terra software, which is an offline software, runs on PC for photogrammetry process that converts all your photos into 2D, 3D models based on the local computing capability. Then moving to 2020, we have released our P1/L1, which is our flagship photogrammetry and our flagship airborne LiDAR solution. And back in the time, these two payloads combined with our flagship M300 platform really provides high detailed, high quality results for customers that seeking for using drones for reality capture purposes. Then moving to 2021, we have this heritage protection contest, which by the time we believe that the sensor has been great enough for customers to start digitalizing their assets and keep a safe digital copy of the historical property. So we started this contest and allow users to use the tools that we have to digital twin and reality capture all the historic assets. Then 2022, which is relatively close or recent, we have released the Mavic 3 Enterprise platform, which is small, compact drone for reality capture work, which is extremely popular, and we're still adding a lot of functionality into it, even today. In 2023, we have released DJI Dock 2, which is optimized for reality capture purpose as well as the 350 or 350 we call, which is the flagship platform we announced to replace the M300 with slight improvements. Now moving to 2024, which is this year, we have announced tons of functionality on the photogrammetry process. Along with Terra, we have a second software from enterprise sites called Modify, which is further post-process your model, which Kyle is going to give everyone a quick introduction toward the second part of today's webinar. Back to you, Kyle.
Yeah, so I'm glad that we were able to set the stage. Let's talk, and we're going to dive straight into mission planning and some of the new updates that DJI has as far as making sure you capture really high quality data. Back in, I think it was day 1, God made the heavens and the earth. Day 2, I think he made 2D map creation mission planning. We've been doing, it feels like we've been going out and been able to automate capture for orthomosaics now for 10, 15 plus years with drones. While we have been able to see the rise of that, a lot of our assets aren't necessarily just a surveyed map. It's not a farm field or a construction site where we're trying to do earthworks. It may be a cell tower, it may be a grain facility, it may be a bridge or very complex buildings or a dam, where we still want to be able to capture every side of the asset if possible for 3D reconstruction and for inspection. But how do we go from just taking photos back and forth with the camera straight down to fully understanding the asset and trying to build flight plans from that? From there are a couple different mission capture methods with DJI. Oftentimes it takes a number of different mission types to be able to fully cover an asset. Ted, I know that you've worked on a number of different like bridge projects and other building projects. What are some of the most common flight plans that you're seeing and you're utilizing?
Yeah, I mean, it's like you said, mapping has been kind of perfected by now. And so whenever you came across these more complex situations where you had to capture images vertically along a slope or a surface, it was always this game of like, oh, I need to go and find the right software, the right mission planning tool for that. And then, next day you're doing something slightly different. And it turns out, the tool you just used yesterday doesn't have the features you need for today. So that from like the boots on the ground perspective, that was always very stressful, right? You had to like really put a lot of effort into planning and thinking about it. And quite honestly, a lot of the times I just stuck to manually flying it. If it was something really complex and like a facade or really vertical, sometimes that was the easiest. But it always starts with what you're trying to capture, right? If you start with that thing that you need really good reconstruction of, and then you work backwards and decide on the tooling that you're going to be using. That's why I'm really excited about the sort of what we're going to be talking about today, because it really simplifies all of that, makes my life a lot easier, makes everyone's life a lot easier in the field, and takes that stress away from it. There's a lot of things on this slide though, right? So it can be a little bit overwhelming. There's all these abbreviations, POI, like linear, like what does that all mean? Hopefully we can break it down for you and give you sort of a feel of what to look for and what to go to first when you encounter something unique.
Yeah, there are times where I definitely fall back too, and I take the manual capture approach, just because you kind of have that intuition after building so many 3D models of what needs to be captured, but it takes a lot of time to get to that process. So instead, let's see if we can, automate missions or be able to build flight plans that are going to be able to suffice. So
you'll still. Sorry, I was just going to add, and you'll still, there's nothing wrong with manual. You'll still benefit from adding some manual shots. So there's never going to be a time where there's no need for it ever. It's only going to help in most cases. So yeah, flying a drone is still a skill, that you should practice.
It is. And most of the assets that you see today, the traditional workflow is that I have seen is, 50% automated capture, 50% manual capture, just based off of intuition. But now if we can get closer to 90% automated and 10% manual, then that would be amazing. Or even closer to that 99 or 100%. But yes,
Go for
always
it.
going to be manual. Cool. Slope route. Run, do you want to introduce the slope route tool?
Certainly, Kyle. And I just want to add on before talking about the slope tool we have or slope route mission plan we have. Like Kyle and Ted mentioned, reality capture, the mission planning is a huge portion because when you capture all the data, the rest of it is just process. And when processing, you just apply a setting profile generally. That's not hard at all. But reality capture in terms of data planning and mission capturing, it can be very challenging, depends on the scenario. So for the past few years or 5 years, 6 years, we have seen a lot of challenges. And people now these days are still flying drones manually because the mission created might not be perfect, covering what they are trying to capture. So when it comes to reality capture, especially for detailed reality capture on large scene, you do want to make sure your drone or your camera in this case is evenly close to the object that you are trying to reconstruct or trying to capture. So that has become a challenge. When it comes to general mapping, that's easy because your surface is relatively flat. But when it comes to terrain, so that's why we have terrain photo, because you want to maintain the distance. If you have a photo that is too far away or too close, that's gonna, at the end, your model is gonna have one spot super blurry and section of the spot super detailed. So the general idea for having this mission is to create flight route along the scene and capture photos have more even resolution. So that's why we have introduced this slope route missions for scenarios such as facade inspection, because we see objects or buildings or artificial objects can be simply interpreted as a simplified geometry. And you can simply define a slope or define a plane within the scene. And then you can simply, based on the scene, generate a flight route. And that's actually, that process automatically done within our software. And how you create this plane can be done in two methods. First method, you can directly use the controller and fly the drone and use the drone's camera perspective to define that plane. And that plane is essentially the surface you're trying to scan. And while you're defining this plane within the camera view, this is almost like an AR view, and you can just simply align the virtual surface or virtual plane within this AR view and make sure everything is aligned perfectly. And by having that virtual plane as a reference, you'll be able to create a route easily. This is the first method. The second method is using our FlightHub 2, which is our online mission planning platform, which is web-based. You can simply pull up a 3D model of the scene if such thing is available for you to provide, and you can simply draw the plane out for the software to recognize the scanning surface, and our software will create flight route with correct parameters automatically. So that process is really simplified. Previously, you may have to fly manually and set a camera to time interval shots, and basically have to be very steady while flying manually and then capturing these photos. Whereas now these days, you can simply use function like this to create a mission. The drone will execute the mission with the obstacle avoidance in mind. So It's safe, it's slow, and it's a lot more even data you captured for reconstruction. And this is currently only available for the small drone we have, Mavic 3 Enterprise. And Kyle and Ted, I believe you guys have tried out this function a lot.
Yeah, I tried this out a few weeks ago for the first time. I actually didn't, I saw a firmware update. I did it and I was like, what is this, right? And to be honest, at first when I saw slope, I was a little confused. Like I was, why is it called slope? When I started using it, it started to make sense because not every facade is vertical, or not everything you want to scan is vertical. I think of it more like surface route, right? What stood out to me right away was the AR view. I was really impressed by the AR view, and it's really sticky. Like you can fly around and take a look at different perspectives from it, and it stays in that real world coordinate, right? Just like it stays in that 2D image you're looking at from your live feed. And that's huge, right? Because moving around and just verifying that everything is lined up perfectly. You want to be able to do that as quickly as possible because the drone is in the air when this is happening, especially when I did it right off the controller. I didn't know that I could start using 3D models that I had already created, and that really stood out to me. Other than that, it's really straightforward. I think keeping it simple is like the key for a lot of things in the field. You don't want to overcomplicate, and as long as you have the right tools for the job. In this case, you got to have some RTK. So I'm sure we'll talk about that later. But as long as you have those two things, which are becoming the norm in the industry, like most people that are in the drone industry now understand RTK. They have access to it. As long as you have those things going for you, then it makes these types of captures really straightforward and repeatable, which is a big thing, right? Because in a lot of the cases, you're going to go there once, you might have to go there again and check on how things changed. So those two things are huge.
Yeah. The ability of saving these missions and then re-queuing them up and getting that inch level flight accuracy so it's repeatable is amazing. And being able to do it with a $700 little RTK antenna on top of an M3E, and then being able to utilize a base station or N-Trip in Iowa, we just hotspot my phone to the controller. I bragged about this like 6 times on webinars.
Gets me every time.
We get free corrections just like that, and we have pretty good cell coverage now in the state, and we're pretty dense as far as our base station corrections. So overall, it's been good. One thing I do want to highlight is how flexible this type of mission plan is. So you can set the mission all the way down to just under 10 feet away from the asset. So you are now looking at sub-millimeter GSD with the Mavic 3 Enterprise, and you can get creative with these missions. Once again, it doesn't have to be straight on a facade. So what if the goal is to make some ultra high resolution map? I could just set a plane, orientate my plane flat onto the ground, and now I have the ability of making a map mission with obstacle avoidance turned on down to 10 feet. So we can start getting pretty creative with these types of map missions. It's not just cookie cutter. Here's the facade, and we're flying buildings. That's the whole goal. It can be a dam, it can be a high wall, and even with this high wall, I mean, you can make a map mission and get some insane detail. And yeah, just be able to re-queue it up and fly that same mission again next time.
Yeah, that distance, especially when we're thinking about like mapping, applying this to mapping is kind of interesting because in agriculture, I've come across situations in sort of like the precision agriculture side of the services business where you're looking for pests in the crop, right? And that's all about resolution, all about GSD, and setting up like traditional map planning. You're always pretty limited by the lowest altitude you could go. With this, you can really get up close and not have to do any of that manually. Like it's not even just all about facades and this type of geometry. You can be pretty creative with it. I think that's pretty cool.
Yeah. And in the AR view, you do get that green line for where the drone's going. So you can kind of see, is my mission going to be getting close to an obstacle, which is nice. So that leads from slope into geometric. how can we automate not just one side of an asset, but can we automate mission planning from all sides of the asset? Much like slope missions, geometrics missions can be planned in two separate ways. The first one would be pre-planning the mission or pre-flying the site. You can do a very quick site with something like, or quick flight with something like Smart Oblique. This is a mission plan around DJI headquarters, but if we went up and just made a quick, or even Ted brought this up when we were, before we even started on this presentation, that you just go up, grab a point of interest orbit, capture the site in a couple different orbit areas, and boom, you have a pretty quick 3D model that you can then plan missions on top of. Right now, both slope and geometric missions, we need to highlight, are only available for the Mavic 3 Enterprise series currently. And so from there, you're going to be able to capture enough 3D data to start building a good 3D model. Ted, or actually let me ask Run, what makes you the most excited going from slope into the geometric mission plannings and being able to automate mission across the entire asset?
Yeah, I think one of the great benefits for having that is instead of scanning each slope at a time, now you have capability to first simplify your structure based on different geometry. Then you can specify certain geometry and optimize your camera settings. So that way you're not only capturing the scene from overview, but also able to capture detailed, because buildings like this, for example, it's not going to be a simple geometry shape after all, but you can have room to play around and further improve your settings and outcome quality.
Yeah, Ted, have you been able to fly with the geometric flight plan yet?
Yeah, I did set up a geometric flight plan for the first time. Couple tidbits to keep in mind that I think are important. When you're creating that base model, right? Orbit is fine. You don't need a lot of detail. Like should be quick. You're gonna probably have a laptop with you because you're in a drone business. You're gonna have a laptop, some kind of computer with you. You want it to process quickly too, right? You don't want to like have to deal with waiting and burning all that time. Time is money. The other thing is when you're creating that baseline model that this route is going to be planned around, it's gotta be RTK'd, right? It's gonna have to start on a coordinate reference system on a datum that it's going to be flown at as well. So keep that in mind. And it's not like you can just like throw in stuff you captured with another drone that didn't have RTK, that wasn't using the same reference system, the same datum, and you're going to have a good time. It's not going to be a good time potentially. You know, it's kind of like a, you know, maybe it will. Like you might get lucky, but most likely you should prepare for that. Otherwise, it's pretty straightforward. Like you just draw a polygon around that 3D model. You may have to use multiple polygons if it's a really complex structure like this, but it's just an iterative process. Definitely take some practice. It's not, you know, just turn it on and forget about it. You're going to get better over time, and you're going to start to be able to approach these really complex ones. Like Kyle, you did this one, and you're going to have a good time every time you try it because you know what to expect. It's all about, you know, having that experience and having some practice with it. It's like an art and a science.
Yeah, there is an aspect of art that it's hard to comprehend kind of what it is, and it's not.
Yeah, I mean, it's a creative process. Like you're taking something and you're essentially painting it in 3D. You know, there is a little bit of creativity in there. You know, two different people may have different approaches for it. What's important is that you get the data that's going to make this next part, the processing, that's going to make that as, you know, as straightforward and least stressful as possible, because it's always good in, good out, right? Versus the opposite. And you want to minimize that, especially when you're doing this, you know, when you're doing this for a living. And again, like you don't want to have to go back. You want to get it right the first time, and you'll learn that lesson pretty quick.
Yeah. Yeah, I like how you said with painting in 3D, essentially. We want to be able to paint the entire asset on all 3 dimensions to be able to build a flight plan. And oftentimes it takes multiple flight plans, and oftentimes it takes multiple types of flight plans. So you can kind of see this Hansher 3D model. I've shared it on LinkedIn as well. This took a combination of mission plans. It wasn't just the other skyscraper where I dropped a big cube or polygon and just pulled it up and hit go. Here I was able to build kind of a top, middle, and bottom flight plan. And you can queue all of these missions up very easily within the Pilot 2 controller. So I just named them Hansher Top, Hansher 2, and Hansher 3. Probably could have done top, middle, and bottom. And then just as soon as I'm done with top, I can easily click it and click middle, and then it's just going to load in that section too. And even for the roof, I grabbed a slope mission just to grab the very top of it at an angle. So it's a combination of everything that you can use.
And when you're switching through these, correct me if I'm wrong, you don't have to land and then take off again. You can, once it's done, you can load in the next mission, just like you do with mapping, load in the next mission and then hit go and it just picks up there.
Yeah, exactly. Yeah, makes the workflow pretty simple of just onto the next, onto the next. And oftentimes these geometric or slope missions, they may only be 2 or 3 minutes, but you have 6 or 7 different things that you need to capture to get the whole thing. So having to land in between is really cumbersome. You can just kind of quick grab this and this and this and then be done.
Yep. Kyle, what about, quick question, I see it in the chat here too. What about changing the gimbal angle? I haven't tried this. I've tried a building and some pretty simple geometry really, but you know, assets in the world are pretty complex. Can you adjust that as well?
Yeah, you can adjust the gimbal angle on the fly for geometric slope mission. There is, especially when you're flying live, there's the aspect of whatever gimbal angle you have set when you press C1, that's what the pitch orientation is of the polygon. But Run, correct me if I'm wrong, are you able to change the gimbal angle in a slope mission live?
Yes, you can. Yes, you can.
Perfect. Perfect. So yeah, if you need to automate it and you don't want to have the camera pointed nadir to the asset, you can definitely change that. Good question.
When I started mapping, I was always very afraid to like touch anything when it was flying, right? But then the more you get used to it and the more like you try things, and sometimes you're trying it live, you don't really know what's going to happen, but you just press that button. Maybe it's by accident. You realize that that's actually a lot of flexibility. It's like, you know, thinking about manual flying. You kind of got to adapt to the situation. You know, I would say there's not much you can do to break it if you just try to change the gimbal angle. It either accepts that input or it doesn't. And at the end of the day, even if you lost a couple photos there, you can always go back and take those photos. That's the beauty of photogrammetry. It's like not live. It's all post. So you can always touch things up if you realize you remember that you missed something or something was skipped.
Yeah.
Actually, I have seen a quick question that I also want to know, because Ted and Kyle, you guys had great experience with geometric route as well as slope route. What do you guys recommend, manual focus or AFC, while operating this?
I'm always very, very, very cautious of what the camera is going to do when it's an auto setting. So when the drone is doing its thing and it's going waypoint to waypoint, my attention and my eyes are on the screen, right? And I'm looking at a few things, but mostly what I'm paying attention to is, does this look like image quality, like the camera settings are appropriate for what it's looking at right now? With mapping, you don't have to think about that too much because you're only seeing light that's bouncing off that surface into your camera from one direction. It's very consistent throughout. But with geometry like this, there are situations, especially when you get to the edge of like the roof line, the eave, the very top, your camera may access. I mean, it's just a camera. It's not like AI. It doesn't really know what is in front of it, what the brightness is going to change. It's trying to do everything for like an average of the frame. It's doing its best, but keep an eye on that. And again, like make sure if you see something that's wrong, hit pause. The drone will just stay there, it'll just hover, and make that fine adjustment, and then hit resume. And it'll save you a ton of headaches down the road because you were paying attention and you fixed that when it was being captured. You don't have to waste more time in the field. You don't have to come back, and you're going to have a better result. You're going to have a better model. It's probably still going to be a model at the end of the day, even if you don't do this, but that's like what separates, I think, the ones that are doing this professionally every day and get like amazing results versus users that just start and then they start to see these weird, you know, maybe shadows that are a little too dark, or the textures are all, they're not blended well. It's just camera settings, right? In my experience, people that are really great at this stuff are also great photographers. Like that they have that as where they started. They understand cameras, like very fundamental aspects of taking a picture, and they're applying it to this flying camera. And that's my take on it.
Yeah, I would say if it's a mapping mission, the traditional answer is have it at manual and set it to infinity. But since we're so close to the asset, I've got a DJI Polo on, and I do trust quite a bit of our auto function, even when we get that close to an asset. That being said, if I'm looking to fine tune or just guarantee that I'm going to be highly focused on what the camera output is, and I might even go to manual. But I've had good success so far with auto.
Yeah, it doesn't have to be full manual too. I don't want to like make it too complicated, but like even exposure compensation, like the EV thing, there's like a dial on the controller that you can like adjust in real time that will just change a brighter or darker overall, and even that can make a huge impact. And it's very, very straightforward to do.
Yeah. Another good question. This one, we were able to throw these slides in literally this morning or last night, because if you check your firmware updates on your Mavic 3 Enterprises, you now will see the geometric flight route is available as a new mission type. So we talked about building geometric routes on a 3D model in Flight Hub 2. You can now, with the AR view in Pilot 2, build these geometric routes live, where you essentially you fly around the asset and you dial in where the asset is, and we build that flight plan for you, and you set your target distance to surface, and you're pretty much ready to go. Obviously, make sure you have your vision assist on, but first off, you'll select, do you want your geometric? We do have the ability of being this like polygon tool, or we can go more cylinder. If you just need a perfect circle and automate a spiral, we can, or at least an orbit. And then from there, you'll use the C1 and the C2 buttons to set the height of the building. And you're going to be seeing a lot of this in AR view. So you can see where the pillars are, and as you fly around, those are going to move. And then you'll just be using the back buttons on the controller, the C1 and the C2 buttons, to set where that polygon is. And then from there, you have in AR view the asset, you build the flight plan, and you hit go, and you're ready. And that's
cool.
I haven't
first
even
time I'm seeing this.
Yeah, I haven't tested it out yet. I'm planning on doing it this weekend, but live geometric flight planning, that's spicy. Yes, I'm excited.
And Kyle, we have a lot of people asking, well, this solution is great. What would be necessary for them to have in terms of utilizing this feature, hardware and software side? Could you give us a little intro?
Ooh, yeah, that's a great question again. First off, it's Mavic 3 Enterprise Series only, so you're going to definitely need that. You're going to need to purchase the $700 RTK module that goes on top. You are also going to want to look into corrections. We talk about this in a slide or two, but you do want to fly with RTK, so that might be an NTRIP service that's close to you. You can fairly easily just look up where NTRIP services are that are close to you. I do shout out to Point One Navigation. You do get a free 2-week trial just by entering in your Gmail account, and they've got pretty good coverage. Here in the state of Iowa, we're fine. We've got coverage there. For processing the data, you can either use Flight Hub 2, a pro account, to process the 3D model to build a flight plan from, or you can use DJI Terra to process that data and run. You'd be better as far as what the specs that we would recommend for Terra processing computers.
Yeah, so basically, since Terra is completely running offline, so you will need to have a NVIDIA graphics card because we use CUDA for our software. So essentially, if you have a NVIDIA graphics card that is running Windows 10 or above with at least, I believe, 16 gigabytes of RAM, you should be able to run Terra. But like Kyle mentioned, all you need for this to achieve this is to have a Mavic 3 Enterprise with RTK plug attachment. And like Kyle mentioned, based on where you're located, some states even have free course network available managed by local Department of Transportation. So you'll be able to access that directly. And in terms of software, it's completely free. So if you have Pilot app, if you want to utilize these latest softwares, we don't charge for that.
It's free, Run. Oh, that's great to hear.
Can I chime in a little bit, because I'm the one here that doesn't have a DJI shirt on, so I think I'm the best thing about photogrammetry is that it's pictures, like, right, you have options. Like, that's what I love about it. You have options, and you always want to have options. So just so people don't get confused, like, I don't think you absolutely need to be using Terra for the reconstruction. Am I right about that? Perfect. The other thing is the N-trip thing. Here in Canada, we do not have the luxury of free public core stations like you do in Iowa. So we got to get a little bit creative. Point one, love Point One, love what they're doing. They haven't come over here though. They're not setting up base stations in Canada. So I got to get even more creative. So you can use the RTK2 if you already have it, right? And you can also use any GNSS receiver. Shout out to Emlid, like, they make amazing receivers. I'm a huge fan. It's got this thing called local N-trip. You can basically set up your own reference station and pick it up and move it to another place, and boom, it's there now. And the other thing I want to add is regulations. Like, you usually have to keep line of sight. Here in Canada, we have this thing called extended visual line of sight, where you can actually use a visual observer. They don't have to have the controls, but as long as you're able to keep in communication with them, you're still good. I don't know if that's the same with the FAA, but if you ever get into that situation, let's say that this geometry mission is coming like around the corner of the building and you're about to lose sight of it, what I would do, hit pause before you lose that sight, and move, like literally move yourself to the other side of that building. The drone's just going to be there. It's safe. It's got RTK. It's not going anywhere. And then hit resume. It's really, really simple. And most of these sort of bottlenecks you come across, there's always a way around them. Just got to get creative in the field.
Yeah, I totally agree. I mean, I feel like we could go on for a couple hours here. Switch the flight plan on the geometric route, switch it to vertical if you're doing a tall building. So you're scanning from the top down rather than having to go around and losing the visual perspective of it every time.
Yeah, so, yeah, that's a great point.
So cool. Let me go ahead and resume. And I know we're running a little bit behind, but let's dive into data capture. There's a few things that I want to highlight as far as data capture. So first off, we've talked about it a little bit already, but the sensor manual adjustments. What adjustments can we make to the sensor of the drone, and how important is that, Ted?
Well, it's like we said, it's pictures. You got to take good pictures, right? And pictures always, it's camera 101, right? Big sensors are generally better. They let in more light. It's all of these things that like come together, and if you're not setting it up correctly, or if you don't have the right tool, again, you're probably going to get something out of it, but it's not going to be the best that you could have gotten out of that hardware. In terms of like manual adjustments, spoke about that a little bit. With these types of missions, keep in mind that your camera is going to be really close to a surface, and just like it says on the side of your mirror, like objects may appear closer than they are. It's kind of like the same thing. Like slow movement will appear to be faster on the image frame when you're up close to something. So what I think about is motion blur. I want to make sure that my camera is set, or the auto settings, or even the manual settings that I have plugged in. Those are going to be at a shutter speed that is able to keep up with that motion and not introduce motion blur. That to me is priority number one. There's no way to fix motion blur. Now, that requires a faster shutter speed. It's okay if you have to use a higher ISO. It's okay if there's some noise. Noise doesn't really affect photogrammetry. It doesn't really make an impact on the reconstruction, the accuracy. It's random noise. So that's like least of my worries. Number one is always blur and sharp images. So focus and motion.
Yeah. Yeah. And the other aspect, corrections, that we were planning to talk about, I think we already covered that as well, but I will give a secondary shout out to the Emlyn Reach product, the RS2, the RS3. It is a drone service provider's kind of dream. As far as base stations, it's a good one to recommend.
I also want to add on that is the results or the data captured only has to be precise. It doesn't have to be accurate. So in that case, you can theoretically use any base station that supports intra-protocol broadcast and work with the M3E drones. So you don't even need to set the base station on a known point or any of that if you just want to have the drone capture accurate data. And I think I have seen at least 5 people asking about this. Why is the RTK puck required? And overall, that's a $700 unit that you have to invest. The reason is we want to ensure the relative, and we want to actually enhance the relative precision and accuracy of our drone. And that's overall what the RTK is meant for. At the beginning, if you actually know a little bit about history of DJI, we used to have M600, which is our big drone, which supports RTK. I think it's one of the first enterprise drones supports RTK. Never mind, second. Anyway, the reason for having RTK at the beginning was to enhance the positioning accuracy. So having RTK for, especially when you're flying, literally like Kyle mentioned, 10 feet away from a building, from any artificial structure, you do want to make sure it's safe while operating. So RTK technology is approach we took to enhance that.
Mm-hmm. Yeah. And if you're thinking about getting into this business of flying drones for a living, do yourself a favor and research GNSS, research GPS, like the fundamentals of GPS, like where it starts to fall apart. You know, in these types of situations, you're going to be close to structures, and that's not the greatest place for GPS, right? If you've been to New York, you know how your Maps app is going to react when you're in Manhattan. There's a reason for that. These are the types of situations you're getting to, and I would expect, like, these are sort of, you know, more pro level type of work, right? This is sort of on the higher end. Make sure you understand the physics behind positioning, so that you don't get yourself in trouble, and you know what to look for and what to avoid. Things like multipath and RF interference, they can all play a pretty big role in this whole part of the photogrammetry process.
Yeah. Yeah. Diving into what would make a good drone for this, and the reason why we chose the Mavic 3 Enterprise to integrate with, is a couple different reasons. We just talked about accuracy. We talked about sensor adjustments that we can make, which is quite a few on that 4/3 inch sensor. But also the sensor itself is really high quality, largest in the industry for the price bracket that it's in, mechanical shutter. It's also shooting at 0.7 seconds. So it's going to speed up a lot of these geometric missions, being able to capture much quicker. Like Ted said, though, you still need to be monitoring for any potential image blur and making sure your shutter speed is set high enough. But if you have that, you can capture good quality data quickly. Also, things that you don't even think about: video transmission range. If you're flying in doing skyscrapers, you're probably in a very high RF area. and you may be going around a corner or something, where you want to make sure you have good quality video feedback with DJI. I feel like we are pretty good at that, maybe even industry leading, so to say. And then also time sync, being able to take the imagery or the GNSS position and actually tag it to the image so you get back really accurate data are very important aspects.
Yeah, you kind of get that for free, right? Since you have to be using RTK, you can almost you're assured essentially that when you throw this into photogrammetry, you can use high confidence on those prior positions. And then therefore the result is going to be high precision. And it removes this thing about GCPs, kind of, right? I mean, it's really hard to set a GCP on the side of a building. You can try, but at the end of the day, because RTK is already there, it's like this nice little bonus. Yeah, I always think about how awesome that is to not have to worry about.
Yeah, and I think it definitely reflects when it comes to the 3D models, being able to both in time and even some on processing quality.
Much more forgiving.
Yes. Highlighting both payloads, we've talked about these slope and geometric missions. We talk about the Mavic 3 Enterprise. That is going to be the best as far as 3D reconstruction. But you still can plan these missions with the Mavic 3 thermal and capture the data. The data is not going to be RTK accurate, but the mission flight and capture will be. So, for example, highlighting a partner Drone Deploy that does do radiometric processing. If I'm just looking to automate a mission and automate inspection of all of the capture locations of thermal for this facade, I can. And then I can zoom in, I can click on each individual photo and see where that hotspot is. So it isn't always about making the best model possible. Sometimes it's just making sure we get images in every single spot of our asset so that we can do individual image analysis like this.
Yeah, a great shout out to Drone Deploy. Whenever I have thermal data that I need to turn into reconstruction, like an ortho photo or a 3D model, like Drone Deploy is my go-to, because anyone that's tried knows that working with thermal images is very difficult to get what you expect to get. But every time I've thrown it into Drone Deploy, it always works. I don't know what they're doing over there, what the secret sauce is. Keep doing it. But like, huge shout out to Drone Deploy for just making this possible.
Yeah, and even just the UI of being able to move around navigation-wise between these photos, I love. Cool. And let's dive into some of the new DJI updates. Man, we're getting a little bit far on time, so we might push over. One thing that we want to highlight is Flight Assist. This is now the new screen that I watch most of the time while I'm flying, especially if I'm flying very close to the asset. In the bottom right corner, you can see, you can tap into the visual obstacle avoidance cameras. And so you can always just make sure you're flying, click forward, make sure you're flying safely. And then you can also get that little camera view to make sure that you're capturing nadir to the asset, which is something I'm excited about. But think about it, this is 2 stereo photos that we're essentially stitching into one, and it does a pretty good job.
Yeah, that's pretty cool. When I first saw this come to the Mavic 3 Consumer Edition, I'm going to be honest, I was a little salty. I was like, hey, I want this. So why didn't I get it on my Enterprise? And then it's here, so thank you. But yeah, I agree. I'm looking at that thing all the time. Why is it black and white?
Run?
I'm not.
Yeah, it's a grayscale. It's actually, we're getting these imagery from the fisheye cameras that are around the drone. So they are actually not RGB cameras. They are meant to be grayscale because the main purpose for having these cameras is for obstacle avoidance. That's why grayscale image has better dynamic in terms of capturing and be able to visualize, see the obstacles.
Cool. I love that nerdy stuff.
Cool. So some of the other features that we pushed, I'm going to breeze through them pretty quickly. Custom breakpoint, it is something I am very excited about. I think Ted and Run are as well. It's something that is came out for mapping missions. and we do expect that to be able to come out for other types of missions in the future. But it is where if you are on a mission and you need to move forward and you can't move forward because there's an obstacle there, you're going to be able to jump around that and kind of hit resume. As well as white balance. Ted, do you want to mention a little bit about what's important about white balance?
Yeah, white balance is like when you first worry about the motion blur and the other stuff that we talked about, and then when you really get good at that, then you can start sort of worrying about white balance. Quite honestly, it makes a pretty big impact in certain situations. Of course, like for photogrammetry, your ideal situation is overcast day. Your white balance shouldn't change all of that much throughout the capture. But you know, if you live somewhere like California, good luck getting an overcast day. You're going to have to think about white balance, because if you want the most uniform and consistent textures on that 3D model, then this is kind of like that last 5% that will get you there. So if it is a day, you know, environment's constantly changing, the lighting is changing, maybe auto isn't the best setting to put white balance. Maybe it's best to just set it when you're on the ground, set it to what you think looks most natural on your screen, and then leave it there. That's probably going to end up being the best sort of setting overall. You don't have to change it consistently. You're not doing yourself any favors by doing that, but just think about it before you start. Make sure it's dialed in, and then think about everything else that we just talked about. Lots to think about.
Perfect. Thanks. My youngest daughter just popped in the room, and so I needed to deflect. But let's dive into data processing, even though we're going to be pushing probably about 15 minutes extra. But when it comes to data processing, there are a number of different workflows and things that you need to think about for outputs. What type of output? Is it going to be two-dimensional? Is it going to be, as Michael Gula says, it's got to be three-dimensional? Or you're going to be looking for digital terrain models? Are you going to be hosting raw videos, raw photos? And then also, how are you going to be processing the data? Locally? Are you going to then, once the data is processed locally, host that model in the cloud to share? Or are you going to send the raw imagery to a cloud host service to process that data? And at DJI, we've got both options. You can either process utilizing Terra, which is our main on-prem Windows-based software processing engine, or if you are processing data in the cloud, you can push it to Flight Hub 2, and it ultimately has the same type of Terra engine in the background, so you should be able to expect the same quality outputs. But Terra, when it comes to 3D models and to meshes and textures, I have not seen many platforms that have been able to compete. But I've been blown away with the 3D models. Let's just keep jumping through. But yeah, Ted, have you been able to test out Terra? I know there are a number of different photogrammetry engines out there.
Oh, I love testing them all out. I got like 6 of them installed on this computer right now. I gotta give it to Terra. It's good. Like it's delivering very crispy textures, and that's like one of the more difficult things to do. You want, like, you're giving it imagery, and you want that 3D model, the texture on that 3D model, to be as close to that original imagery as possible. Now, it's always a destructive process. There's just fundamentally no way to get a one-to-one like pixel representation into a mesh, right? There's UV maps, there's all of these things that kind of have to be done for it to end up looking like a 3D model with a texture. But Terra's doing a great job. I mean, that is one of those things that depends on what you're going after, right? If your client who's paying for this, right? If that's what they look at first and are going to be amazed when they see this, then Terra is a great option for that. If it's less important, then you have other options. You don't really have to worry about it so much. But props to whoever's behind the Terra engine. You guys are killing it over there. I'm really impressed, and it's improved very quickly. That's the other thing. I love like options, right? I want this industry to grow as quickly as possible and keep growing. And options are how we get to that stage. And props to Terra for being hitting so high so quickly.
Yeah, there have been a lot of adjustments recently. We just pushed out Terra 4.0 in the past. I think it was about 2 months ago. And yeah, when it comes to 3D, I do really like Terra. Some of the other strong points would be ease of use and cost. In the ease of use of Terra, how many clicks has it run to go from data set to 3D model? 7, something like that?
Yeah, something like that. It's not really some difficult to use. It's a very intuitive software. If you're used to DJI flight controller software, it's not hard to use. There's not like tons of settings, but all the necessary settings are going to be there. So if you need to play around with it and just to, those options are there.
Yeah. Well, someone in the chat asked, is all of this possible with the Mavic 3 multispectral? Yes, thanks for asking that. I have the multispectral. I can confirm it works with the multispectral.
Good. Yeah, there are quite a few of those M3Ms out there too. So glad that we're able to support that. Yeah, and the textures, I'm just going to keep talking about them. This was an orbit that I did with the point of interest tool of a cell tower, and this flight was 8 minutes. So maybe not even that. It was 812 photos captured at 0.7 seconds. So being able to get really high accurate photos, really good photos, is going to be able to generate outputs like this, where you're going to start making measurements of these parts on the cell tower even.
And another Terra shout out, or the engineers behind Terra, the lattice, the thin structures. Terra does really great thin structures, thin lattice structures, like those wires. That's like the kryptonite of photogrammetry. Thanks for what you're doing over there, whoever's behind that. A high five. Like that's always been one of those things that is just like very annoying and very difficult to get right.
Yeah. And we have another customer asking, this might be a little bit off the topic, but they're wondering what time they should turn on or turn off the dewarp options. Because generally we recommend to turn off the dewarp option. But Kyle, you might have a answer for this.
I guess I would also kick it back to both of you guys.
Off.
Just leave dewarp off, because accuracy wise, that's what you kind of want to go for.
I would say
don't touch it.
Yeah,
it's default off.
Yeah,
default
always
off,
turn
right?
it off. The only time you
it.
probably want to turn that on is for visual representation, because we actually write these parameters into our cameras, so they would get developed in the post-processing phase. So don't turn it on, ever.
Photogrammetry 101 is we want the most boring, most untouched photo that sensor took. Dewarping is great if you're shooting, real estate photography. We don't want it for photogrammetry. It's only going to create problems for us. There's a reason why it's off by default. Leave it off.
Yeah. Good. Well, with that, we'll keep moving on to the data analysis piece. There's a lot of difficulties when it does come to flying these data sets, though, that even DJI, Terra, and some of the other engines out there can't solve. We're flying around, if it's a skyscraper, oftentimes it's reflective surfaces. We might be flying, along a river, or we may have just a lot of extra floaters from over capture. Now, the data of the actual 3D model is good, but all of that extra noise can kind of make the 3D model end up looking pretty poor. So we want to be able to edit the 3D data as well as then run it through an analysis engine that, Ted, you ran some pretty cool crack detections on a runway that we'll step into here in a minute. But just a quick data analysis workflow. And what you can do with that data, but diving right in with modify. This was just a 3D model that I captured of a bridge. So I did a mapping mission and I did a slope route on either side of this bridge. And you can just click through basically from the very top. You can remove the floating points. I can then start adding in an artificial water surface. I'm going to go through and delete all of the water that looks kind of funny that is next, but I'm going to keep the trees there just as documentation. But one of the most, I would say, relaxing things as someone in the GIS industry is to clean a 3D model. And so sitting down, taking the data into Modify, tipping the building upside down and essentially scooping out all of the floating points, flipping it back right around, flattening out any of the reflective surfaces. It's fun. I like cleaning up models.
Hey, I thought I was weird. I'm glad it's you too.
I'm not sure if you've spent much time in Modify Run cleaning models. Have lost a couple hours in there?
Yeah. Weird thing is, yeah, I spent a lot of time modifying, trying to clean up everything.
Yeah.
Because like you said, like Kyle mentioned, you are going to have some weird tile points generated during the aero triangulation phase. That's unfortunately that's how it works in photogrammetry. But able to clean those out and perfect them, it's great.
Yeah. Yeah. And then from there, we've got one last update on our side. Actually, we'll let you talk about this for a minute, Ted, then we'll get into our last updates. But another analysis tool, and you're able to capture this with the P1.
Yeah, we did this. This is probably about a year and a half ago, but it always keeps coming up. Same with if you're on LinkedIn, you may have seen this bridge that has like these blue blobs on it. The LinkedIn bridge. This was done after, so straight on the ortho. So when we're talking about like what kind of outputs do you want, it really just depends on like what you're looking for, right? So if you're looking for cracks on a runways are flat, you can stick to a two-dimensional data type like orthomosaics. This was actually done by a company called Arin. Their website's arin.ai. They'll take any data and they'll do this type of analysis for it. So this was a 2-kilometer long runway. And this was sort of like a research project that we did at my college. We scanned it first with a P1, aiming for like the best resolution we could. We got about 3 millimeters across that runway. That scan took about 2 hours, so very quick to get like that huge area. And then when we put it into Arin, we got this. So if you look at all those red lines, those highlights, those are cracks that have been identified and then highlighted, so they're very visible. If you took all those cracks and you measured them and you put them end to end, it was 24.5 kilometers of cracks that this picked up. It's pretty incredible. And this is no human interaction. Like they have an AI that's specifically trained for this stuff. It does all of the segmentation based on the surface and the material. And this is like where I get really excited because this makes drones more and more important. This elevates the industry. This keeps me taking pictures of the ground and concrete. Like I said, that's what I want to keep doing. And this is really high value. Like, imagine having to do this manually, like weeks, right? Like who is going to do that? You're not going to finish, but this was done in like 2 days with this system. So I love this part of what can be done, and that's arin.ai, AREN.ai. Shout out.
It's so cool. You can even see where they went in and maybe filled in cracks previously, and it didn't even necessarily pick those up because they were filled, but it went through and picked out the things that would still need to be patched.
Yeah, which I thought was going to be a whole other problem after they ran it, and like, oh, it's going to be a lot of duplication, but no, it nailed it, and it gave each crack segment its own ID. You see that number next to it? That relates to a spreadsheet with as many lines on that spreadsheet as there was cracks that you saw on the other slides, and each one of those goes even deeper and tells you like the width, and there's just so much. I did a whole webinar on this. It's on my YouTube. If you search SkyDeploy, all my webinars are there. There's like an hour and a half about this. Go watch it if you think it's interesting. But I think this is like where things are going, and there's so much value here, and a lot of safety as well, right?
Yeah. But from this, it required good mission planning, good quality optics, good sensor adjustments, good positional sensor accuracy, and then also a good processing engine to get the outputs to run the AI on.
Yeah, it all comes together.
Cool. So some of the updates that DJI has for specifically Modify, we just released, it was probably about a month ago now, that you can start sharing your 3D models that you've processed in Terra into Modify on the cloud. So the 3D model of the church that I've already been able to process, I cleaned it up, removed the floating points or that bridge that you just saw. I can then hit share within my modify software. It's going to give me both a URL and a QR code that you can scan. And with that, you're going to be able to then pull that up, whether it's another computer on a browser, or you can even view these 3D models on your phone. So a high quality sub-millimeter GSD resolution mesh that you can just view on a browser in your phone is just, I'm super, super excited about it. And we're able to have about up to 60 gigabytes of storage at any point. So if you remove or if you delete a model off of your cloud account, you're going to get that storage aimed back to you. And if you do go onto our website on Modify, you can sign up for a free 6-month trial, because we really want customers out there to dive deep and see what the product can do. So with
Very
that,
generous.
yeah, that's what we like to do around here. Cool. And obviously the data, it's all going to be stored on AWS in the United States for any data that's going to be captured in North America.
Yeah.
Cool. We're going to go ahead. I know that we're 6 minutes after, but we're going to go through some more of the questions, and you can get any more questions in that box while you still can. I am going to leave a QR code up here. This is a free try to test out DJI Terra. We walked through a lot of Mavic 3 Enterprise and mission planning today, but the ultimate goal is then to have anyone out there that has this hardware to go out and try it. It's completely free to do these slope missions, geometric missions. So go out and capture some of that data, point of interest missions, and then let's see how good Terra is able to process that data. And I bet you it's going to be one of the better 3D models that you have seen, just based off of the photogrammetry engines I've tested out. So here's a free trial of Terra. I'll leave that QR code up on the screen for a little bit longer. But any questions that run, Ted, you guys see in the chat?
There's a lot of questions, and we still got like 250 people here. So people are definitely engaged. Here's one, and I don't know the answer to this. I'm gonna ask you guys. Can you use the zoom camera from the Mavic 3 Enterprise in the geometry or slope? This is actually a very good question.
Yeah, you're just going to be using the wide camera.
Wide camera.
Yep. I was going to say if you're using the M3T and if you're viewing the side-by-side mode, but I don't think we allow you to view side-by-side while you're doing a slope mission, just because when you do that, it will automatically zoom into 2x. And we know that the data coming out won't be good. So nope, just the wide.
Yep. And honestly, my take on that is you don't need to be using the telecamera. Can't really see a situation where you would want to use a telecamera. It's not as good of a sensor. It's not meant for this. And get closer. Like if you want more resolution, you have that luxury of just getting up closer. And that can sort of deal with all of those issues that the telecamera you would have thought was your savior for. That's the beauty of photogrammetry. It's very flexible, and then your distance to that surface is really the thing that determines the resolution or the GSD of that reconstruction.
I'm not sure if time sync works on the telezoom camera if we're saving with GNSS. I'm not sure.
No, it doesn't.
So your data is not going to be as accurate either.
Yeah.
For the tele camera, no, because the main camera from the M3E and M3M drones are only optimized for time sync.
Yeah.
Because they're mechanical shutter.
That's a good point.
Yeah, another thing with camera while you're flying is just it might get blurry since it's not mechanical shutter camera.
Yeah.
And we will also follow up with some of these questions. We'll download the Excel spreadsheet and send this out to our mailing list. So if you don't get a question answered now, then we will make sure to follow up. But is there one or two more questions that you guys see that are kind of piquing your interest?
I see one here. I think this relates to the part where we're talking about white balance. Is there a huge advantage in using a calibration panel? Like you may have seen like one of those panels with like squares of different colors. Short answer is if you have one, sure, use it. How you use that, there's tutorials on YouTube on how to use it. This is like basic photography. My approach to it is I don't even bother. I just take maybe a picture of something that's approximately white, and that's going to be what I calibrate off of for white balance if I'm making any changes to those photos later on.
Yeah. It looks like, Ron, you did a pretty good job of getting some of the things answered too.
Yeah, well, I know we still have a lot more questions, but yeah.
One question I did get is if you process a 3D model, what 3D model import file types does FlightHub 2 support? So you can build a 3D model off of a 2D ortho that you upload. You could build a 3D model off of a point cloud. The point cloud needs to be LAS, and I think, can we enter in points, maybe?
Yeah.
So if you are looking to automate a mission around a LiDAR point cloud, you can. And then for 3D models, it needs to be B3DM. Do we support any other file types?
I didn't have success with OBJs when I tried it. But yeah, B3DM is the one. It's also the one that's default when you run something on Terra.
Yep.
That gets into the whole other like world of 3D modeling. But once you have it and you have the data, and you have the photos, you have the luxury again, photogrammetry. How amazing! You can run it again, right? If you forgot to check one off, or maybe you need another version that you never thought about in the beginning, reprocess it, make sure that version or that output is enabled, and you're going to get the same result, just in a different file type that you need now.
Yeah, and actually I've seen a lot more questions are actually related to like camera settings and the photogrammetry backgrounds and serving backgrounds actually. Just letting everyone know, we have a YouTube channel. It's named DJI Academy. And later this year, we're planning to upload some training videos there to cover these topics. So highly recommend you guys to subscribe. The YouTube channel we have, it's called DJI Academy. Kyle and I will be making some video courses there to cover surveying topics such as coordinate systems and others more in detail.
Yeah, I've got the screenshot. We posted 2 months ago, more detailed walkthrough on slope missions, rather than today we talked more high level about making these types of missions. But if you need to learn step-by-step guide, check out the DJI Academy channel. Good. I think that's a great place to stop, because we could be sitting here all day, but I really, really want to thank you, Ted, for joining. Your expertise in this topic is, outstanding, and we love to get that perspective. And Run, just for how long that you've been at DJI and being able to follow the product knowledge here, we really appreciate it. So any other questions, feel free to get them in right before we head off, but thank you all for joining.
Thanks, everybody. Thanks for having me, guys. It was cool to be here and talk shop with you. Follow me on LinkedIn if anybody's in the crowd and wants to learn more. I share a lot about this stuff, and I'm happy to answer any questions and more technical things that we can deep dive into. Always there.
Perfect.
Thank you, everyone.
Thanks, everyone.